Alright, in this video we're going to look at vertical shifts for sine and cosine functions. So recall from transforming functions that we shift functions vertically by either adding or subtracting a value from the function itself. So if we add a number to a function, then we're going to move that entire graph up that many units. And if we subtract a number from the function, then we're going to move the entire graph down that many units. So for sine and cosine, your vertical shifts become sine of x plus some number d and cosine of x plus some number d. So looking at sine of x, as we just add larger numbers of values of d, notice our graph goes up. And if we reset this to 0, and if it's sine of x minus, then it'll shift our graph downward. And same effect is going to happen for cosine of x as well. It's going to move the graph up or move the graph down depending on whether or not d is positive or negative. So, determine the vertical shift for each of the following. We have sine of x plus 3. So if we look at our sine of x function, here's sine of x, and here we have y equals sine of x plus 3. Notice it just took this original sine graph and moved it up 3 spaces, which we can see with the plus 3. So our graph is going to move up 3 units. Part B, cosine of x minus 1. We will look at, here's our cosine of x, and y equals cosine of x minus 1. Notice it took the graph in green and just shifted everything down 1 unit. So cosine of x minus 1 is a vertical shift down 1 unit. All right, example C, 2 sine x minus 4. Now, if we take a look at our sine of x function, here's our y equals sine of x. If we look at 2 sine of x minus 4, what happens is, notice our minus 4 graph it's a bit taller. We stretched it vertically, but in terms of what happens, yes, we did stretch it vertically by a factor of 2, but look at the intercepts where our original graph equaled 0. Now those points are 4 units down. So the 2 out in front is a vertical stretch, but the minus 4 afterwards, that is our vertical shift. So be careful when there's other transformations involved. This one is down 4 units. So with vertical shifts, I like to look at where it hits the x-axis originally, where the original function hits the x-axis, and then from there determine, oh, okay, we moved it down 4 spaces. So be careful with those. All right, finally, y equals negative 0.5 cosine of x. So here is y equals cosine of x, and here is negative 0.5 times the cosine of x. So again, the negative is a reflection over the x-axis. The 0.5 is a vertical compression towards the x-axis, vertical compression towards the x-axis. But as far as shifting the point up or down, there's nothing that was added or subtracted afterwards. The y-intercepts didn't move at all. So with this one, there is no vertical shift, or you could say there's a vertical shift up or down 0 units. It really doesn't matter. Any of those 3 is going to be okay. All right, so that does it for vertical shifts. I will see you